All right, so this is going to be the kind of first video that you guys see for the year. So we're starting off with, all right, Unit 1, Lesson 2. All right, and you can see this can cover two of our first parts of our standards here. Standard 1.1, I can identify a linear function from a table of values. And standard 2.1, I can identify the rate of change for a linear function from a table of values. And that's really going to be how the lessons are set up this year. We're going to kind of work with pieces of standards, maybe whole standards, but this is exactly what you can read every time we do a lesson to know kind of what the point of emphasis and the focus will be. All right, and now here's what we do typically every time with a lesson as well. All right, is an opener of some sort, right? And this is to get you thinking about things, to get you, all right, kind of in the right frame of mind, all right, for what we're going to be talking about. Okay, so, and this is typically how it's going to work. I'm going to ask you to do the opener on your own. All right, so you'll pause the video, you'll read the problem, you'll answer the questions for the opener, and then you'll turn the video back on. And then hopefully, as I go through the problem, all right, your work will match my work. Now, if it doesn't, all right, and you don't understand why, all right, put a star, highlight it, do something, and those are the questions you should bring to class with you for us to answer. All right, so let's go ahead and do that. So what I'd like you to do right now is go ahead and pause the video, all right, read the problem here, all right, answer these 4 questions, flip the video back on, and we'll see how you did. All right, so you have a new cell phone contract, right? You had to pay $250 right away, and we want to kind of figure out, like, what is your monthly payment here? All right, so the way we're going to look at this is if we look at what's happening here, you can see the total amount that you have spent, right? And so I look like $30, 30, 30, 30, 30, 30, right? But now the key is this is how much you're spending, but then we have to compare it to something. And so we come over here to the left column, right? And notice these are the months. So my months are going up by 1 here. So what this is telling me is I'm paying $30 per 1 month. So how much am I paying each month? I'm paying $30, right, to 1 month. All right, so how do I know? Well, that's all the work that you did right here, right? Looking at the change, all right, the change in how much you spent to the change in months, right? So this rate of change here, all right, 30 to 1, 30 to 1, 30 to 1, 30 to 1, right? Looking at how does my total amount spent compare to the amount of months? And so which of the 4 functions do you think this is, right? So we have linear, absolute value, quadratic, and exponential. And then what hopefully you said was this was linear. And then hopefully the reason you said this was linear, all right, the reason why is that we have what we have and what we call a constant rate of change. And that's how we know it's linear, right? And there's another thing I'm going to add here, and I'm going to just kind of put this here, and there's in one direction, correct? All right. So it's a constant rate of change in one direction. It doesn't turn, all right? Because we saw in some of our earlier work, the absolute value graph has a constant rate of change, but then it also changes direction. So we have a constant rate up and then a constant rate down, or vice versa, a constant rate down and then a constant rate up. So we have this constant rate of change in one direction, right? It keeps going up by 30. All right, so hopefully you did well on that. All right, now the next piece that we typically do is that we'll maybe have some kind of note taking here, some definitions, some key terms, vocabulary that you need to be aware of. So let's talk about initial value. So initial value, all right, is really what we think about kind of as like the starting point in a problem. All right. Now, how do we know what that is? So typically the starting value or the initial value, the starting point is, all right, when, all right, x is equal to 0. So that's our initial value. So right here, all right, that is our initial value. And that kind of makes sense. That's at the beginning, right? Initial means beginning, right? So as soon as you pick this new cell phone contract, right, you pay $250 right away. All right, you walk out of the store with your phone, but you had to lay down that $250 right away. All right, so rate of change. All right, so rate of change is a ratio. All right, and it's a comparison of the change in y to the change in x. All right, so change in y to the change in x. All right, so that's a rate of change. Now, when it's constant, that's how we know it's linear. So, and what we're going to explore is what happens when it's not constant? How does that tell me what other kind of functions or behaviors I have? All right, and then we have our unit rate. And what this means is that when we do our unit rate, okay, we have our change in y to our change in x. And so when we have a unit rate, what we're saying is that we're looking at the change in y to one change in x. All right, so one change in x. So the denominator is going to be 1 when we look at that ratio. So for example, we go back up here, this was 30 to 1, 30 to 1, 30 to 1. So this 30 to 1 right here, excuse me, let me pull this back down so you can see it. This 30 to 1 is a unit rate. All right, so it's per 1. So when we say unit rate, it's per 1. All right, and so notice maybe if I looked at, maybe my bill got lost in the mail, right? And I noticed, oh, I paid $60 for 2 months. $60 for 2 months. And we said, okay, well, how much do you pay per 1 month, right? Then we have to reduce this ratio. And notice if I reduce that ratio, I get 30 to 1. And so our unit rate would be 30 to 1. All right, and so we really want to get in a habit, all right, of reducing our rates of change till we get to 1 here. And that really helps us see if it's going to be equal or constant. All right, so there's some, all right, initial vocabulary, some terms that you need to be familiar with. Once again, if there's anything that I went through here that you didn't understand, one, you should always write it down. Okay, may not make all the sense to you, all right, but then once again, star something, highlight it, all right, and then when we get to class, right, that's when you say, hey, could you give me a little bit more on initial value? Could you give me another example of this, right? Or could you show me another way of looking at unit rate? Whatever your question might be, then we'll answer that when we come back together in class. Okay, so let's flip over, and then the next part is that we typically go through some of the whole class practice problems together. All right, and we look at those, and you're going to kind of work those with me. All right, and so that then we can come to class and be ready to kind of jump into some group problems. So let's look at problem 1 here. And so notice what it asks us to do here. For each table represented below, identify the rate of change and identify the type of function represented. So when we look at rate of change, so once again, I'm going to just write this here. Our rate of change, right, is our change in y to our change in x. All right, and then based on that, we should know what type of function we have. So what we want to do is we want to look at each side of our table and we want to write out the changes. And once again, don't be lazy here. Don't take the shortcut and try to hold it on your head. Get in the habit of writing things down. All right, it's really going to help you see things, all right, in the long run. So when I look at my table here, notice I go from 12 to 18, so I go up 6. 18 to 24, I go up 6. 24 to 30, I go up 6. 30 to 36, up 6. And what you see is that my y's go up by 6 the entire time. Well, let's look at how our x's change. And notice our x's change by 1 every time. So when I look at this, my rate of change, what's my rate of change? It's my change in y to my change in x. And so my change in y is 6, my change in x is 1. So it's 6 to 1. And notice that also happens to be my unit rate of change because we're looking at it per 1x. So my rate of change and my unit rate this time are exactly the same. And then notice this time too, it's 6 to 1, 6 to 1, 6 to 1, 6 to 1, 6 to 1. It's constant. No change of direction. It's going up by 6 every time. And hopefully what you're thinking right now is that that is in fact a linear function. Okay, so let's jump to problem 2. All right, now, once again, we're going to look at our table. All right, we're going to look at our change in y, then we're going to look at our change in x, and we're going to see what happens here. So I go up by 3 here. I go up by 3. Up by 3. And once again, at any point in time, if I'm going a little too fast, remember, you can always pause the video, write a little bit, turn it back on. All right, so I'm trying to pace myself, but I get excited. I'm a nerd. All right, so I may get going too fast at times. So just remember, you can always pause, write what you need to write, flip it back on. All right, and notice if I continue that pattern, it goes up by 3 every time. And then I jump over here to my x's. And once again, much like number 1 here, all of our x's, all right, go up by 1. So once again, when we look at our rate of change, it's the change in y to the change in x. And that's 3 to 1. So once again, this happens to be the same as our unit rate. And once again, it's constant the entire time. So this is in fact linear. All right, so here's what I would like you to do is we're going to do number 3 kind of in pieces. So what I want you to do is I want you to find all your rates of change for Y, okay? And then stop, turn the video back on and go through it with me, make sure they match. And then we'll do the change in X's and then we'll go through everything else, okay? So right now, find all your changes in Y, just like I did right here, all right? And then flip the video back on and we'll see how you did. Okay, now let's look at the work you did here. Hopefully you saw that, oh, I went down by 20. I went down by 20. And so if I look, all of these do in fact go down by 20. So hopefully that matches what you have. Okay, now pause the video and do the change in X's. Okay, now once again, we can see that these all change by 1. Okay, all right, now once again, pause the video and do these 3 things and let's flip it on and see how you did. All right, so once again, rate of change is change in Y to the change in X, and so that's down 20 per 1. That unit rate is exactly the same as our rate of change this time, and that also means we have a linear function because it is constant in one direction. All right, my friends, so there's our first video of the year. All right, so once again, bring this with you, have your binder with you, and we'll jump right into this in class next time.